Okay, folks, welcome to Lecture 6. In this set of videos, we're going to talk a little bit about correlation. This is going to differ a little bit from some of the work that we've done for the last several weeks with the t-tests and the ANOVAs, in that we're not comparing things anymore of this compared to that. Instead, we're looking to determine whether a relationship exists between one variable and another variable or not. So in the set of videos that we're going to have for this section, we're going to cover 5 things. The first is going to be the basics of correlation. The second will be the difference between variance and covariance. The third will then go through the process for performing a correlational analysis. The fourth will be something that's known as partial and semi-partial correlations. And then finally, as we've done with all videos this term, we're going to end by going through some non-parametric equivalents if our data violates the basic assumptions for these tests. So if you're ready to get started, let's go ahead and dig in. Okay, correlation. Correlation is all about determining the relationship that exists or lack thereof between two continuous variables of interest. And I want to go off script a little bit here because I think one of the key things that you should be familiar with is that we're no longer dealing with independent or dependent variables. Instead, the independent variable is now called the predictor, and the dependent variable is now called the criterion. And so it's very common for people to say, well, independent and dependent variables, that's not quite precise when we're talking about correlational analyses, because we're not looking to determine if the dependent variable of interest is changing because of a level of an independent variable. Instead, we're measuring two continuous variables simultaneously or very close to each other, and we're trying to understand whether as one variable changes, is another variable changing. So that's a very distinct difference in this section. The other thing that we're really interested in doing is identifying possible patterns that may exist in our data. So sometimes correlational analyses are things that have the ability to find new relationships that we've never previously thought about before. In a non-health sciences situation, you might think about things such as what is the relationship between the ambient temperature and changes in our climate with health, right? So you might say, well, and so if we have a higher temperature, you may sweat sooner, and that might make the plasma volume of your blood drop to be a little bit more concentrated. And so that increases your total peripheral resistance in the blood, for example, and that increases your blood pressure, which is a risk factor for cardiovascular disease. And so it's something that generally we don't think about as a scientific inquiry of this does that. But instead, when we allow people to live in their natural environment and we measure variables collectively, we can see that things may influence each other that we've never thought about before. So correlation can be really powerful in that. And so to give you a schematic for how this looks, I'm going to show you a couple graphics. The first one is what we call a positive linear relationship. And as the slide shows, as one variable is increasing, the other variable is also increasing. And so the x-axis, which is the horizontal axis in this case, in this example, you can see its age. As a person's age increases, the y value also increases. And so you have these sort of intersecting points, or these red dots, when we find the xy coordinates, and we can generate something that's known as a line of best fit, which is the line that goes through all of the data points and tries to identify the least amount of error. But we also know that we can have something called a negative relationship. And in a negative relationship, what happens is you see that as one variable increases, the other variable decreases. And you can see that here. And so it has a downward slope that you can see. And that is representing that the variables are related, but they are what's called inversely or negative related, which represents that. The third then kind of relationship is the lack of a relationship. And so as one variable changes, the other variable is not changing up or down. It's just staying flat. And so you typically can identify these in a scatter plot graph like this. And it's denoted because there's this sort of horizontal line that goes through all the data for the line of best fit. It neither slopes upward or downward, which indicates the lack of a relationship. But as we continue to move forward and prepare to get into variance and covariance, one of the things that we have to make sure that we still remember from the comparison testing lectures we've done this term is the concept of deviance. And so remember, deviance represents the distance of any one particular point in a data set, any one person's value from the mean value or the average value. And so graphically, we can see this here. So if we look at the x-axis at the bottom of the slide, you can see that we have 5 people. And on the y-axis, you can see that in this particular example, it's based off of advertisements and packets. So it's some type of business or marketing type of research question. And you can see the -3 represents that the average number of packets for advertising may have been 11, but for this particular person, it only took 8 advertisements to translate that into a purchasing decision. Whereas other customers may have had to receive up to 14 different advertisements and packets in order to influence their buying decision. And so when we look at this, the distance of any one data point from the average horizontal line going across, in this case, the green line going across the top of the screen, this represents the deviance of each individual's value from a mean value. So I hope this first video is helpful. In the next one, we're going to start to talk a little bit about variance versus covariance. We'll see you there.